Hi everyone, so this video is for section 4.5, the derivative and the shape of the graph. Okay, so we're gonna talk about derivative and analyze the shape of the graph. So let's take a look at these pieces of graph. So if I have the graph like this, right, from A to B, if my graph is going from this way. So it looks like the graph is actually increasing. So what about the slope? Isn't that if I put a point right here, I draw a line, the line is going up. When you're going up, you're going to have the slope is positive. When you're going down, you're going to have the slope is negative, right? So since when I put in every single point in between A and B, I can see the line is actually going up. So which means my slope is positive. Slope is positive. Okay, slope is positive. And you can see the graph is going this way. Is there another shape of the graph is also given you the slope is positive? Let's look at this one. If I have this way, okay, you can see the concavity of the graph is actually different. This one is look like the facing up, this one is facing down, right? So if I have the graph like this, the graph is still from left to right is still considered as increasing because it's go up from left to right. If I pick a point right here and I draw a line, pick a point right here, draw a line, it look like the line is also going up. So you have the slope is positive. Okay, so what is this two graph is telling you that if my function is increasing, okay, you will have the slope is positive. Or the other way to say, if the slope is positive, the function will be increasing on the interval, on the given interval, not the whole entire function, but on the given interval. Okay, so let's look at the other shape of the graph. I can also have the graph look like this. And this is decreasing function, right? So if I, between A and B, if I draw a point right here and I draw a line, it's look like the line is actually go downward when my slope is negative, So one more cases, we may have the line is going up. This is going up, right? We may have the line going down this way, but look at the slope. The slope is also downward. So the slope is also negative, right, between A and B. So from these two pictures, we're telling you that if the slope is negative on the interval, on the whole entire interval, then we can say the function is decreasing on that interval. Okay, adding more thing into the graph, adding more information. So let's take a look at this graph right here. Take a look at this one. Okay, so if I have the graph from A and the graph is going this way, okay, so isn't that the slope is actually increasing right here? The slope is positive, not increasing. The slope is positive. Now on the other side, I mean the same graph, I gonna have something like this. So right here, I will have the slope is negative. Okay, so it's look like if the slope or the derivative is changing the direction or changing the sign, I will have a point right here called relative maximum, right? So relative maximum, the point right here is called critical point because relative maximum will be occur at the critical point. So this critical point right here will consider a relative max. Relative max. Okay, or maximum, absolute maximum, big on this one, but we don't know how the graph on the A and B outside the A and B, so we cannot say this is absolute. We can just say relative max, okay? And if I have the other one, let's say look like this. Okay, So you can see there's a relative mean right here. Relative mean. This is relative mean. And look at the slope or the derivative on both sides of that value. If I pick a point right here, my slope here is negative. And if I pick a point right here, my slope here is positive. So what telling you, if your derivative is actually changing sign at some certain point, then this means at that point, you're going to either have a relative max and relative mean. So how the sign will be changing? If you go from positive to negative, you're going to have a relative max. So if you go from positive to negative, yes, you have the max, right? But if you go from negative to positive, then you're gonna have your mean. This is called the first derivative test. Okay, so we're gonna generate that. So the first derivative test is saying that suppose f is a continuous function on the open interval, contain the critical point c, and f is differentiable over I. F prime will be changed from negative to positive as C, then F has the relative minimum as C and F of C. F prime change from positive to negative as C, then F has a relative maximum at that point. But if you have F prime is positive or negative on both sides, then no relative max or relative mean occur. So what did that mean? If you have this is increasing on the C and the other one is also increasing, they have the same sign, then you can have no max or no mean.